Hi. Today I'm gonna make a new video for your homework 2 guide. So you see this homework 2 file now. All right. Well, actually, you might be overwhelmed with these pages, 10 pages long, but you don't need to surprised. Okay. Part 1, Part 2, Part 3 are exactly the same as the midterm exam. But why do we do this? Because we change the data and then we want to redo the same job based on different data sets. So you can refer to the video guide posted in the Sakai when you use which one was it? The midterm exam guide, right? And the last section, GLM, general linear model. So this is most of students will use this function, this SPSS menu for your final paper also. So why do we have to use GLM menu instead of part 3 regression menu? This regression. Well, both of them are multiple regression, but regression, when you include categorical variable in the regression model, you have to manually convert that into multiple dummies. For example, you have urbanicity variable, which includes 3 categories in it, in one variable. Urbanicity coded as 1, urban is coded as 1, and 2 is 4. Suburban, 3 is for rural. So you have one variable, urbanicity variable, but one variable includes 3 categories, 3 subgroups. People who live in urban area, people who live in rural area, people who live in suburban area, okay? So 1 to 3. You cannot use the variable as it is if you use regression tab. So model summary ANOVA coefficient. You remember that? You have to do that. Because SPSS is a machine. So SPSS can think like urban 1, suburban 2, rural as 3 is higher than 1, 2 is higher than 1, something like that. But you didn't intend, you didn't mean rural is higher than urban or rural is higher than suburban or something like that, right? So what you need to do is just you have to change that into multiple dummies. So when you have k number of categories in your categorical variable, you have to make k minus 1 dummy variables. So in this case, urbanicity has 3 categories. So k equals 3. So you have to have 2 dummies because k minus 1 is 2. Okay? But, okay, if you can do it, you can do it. And that it is also posted in the Sakai how to manually convert the categorical variable into multiple dummies. But I am kind of a lazy person, so I don't want to do it, manual conversion of variables properly. So just if I were you, I'm gonna use GLM function rather than regression function. GLM menu can automatically deal with the categorical variable as dummy variables. So we don't need to change that into multiple dummies, okay? But the output shows the separate dummies, categories in the output, okay? Anyway, today's video is about homework 2, so let me just focus on what I'm trying to do. So this is part 4. Okay, part 1 through part 3, you can refer to the midterm exam video guide. And for the last section, you're gonna use this video, okay? So here, number 1 question is about kind of the difference between experiment and observational study. What we are doing in social sciences, most of the study is observational study, not experiment. Okay, this is not laboratory experiment. Okay, so you can't say about cause and effect under the survey observational data study because it's not controlled, right? So, but we use observational study data, and this is about association. This is not about causality or causation. This is about correlation. But in the correlation, you do not have which one was first, which one was less. You just have association between two variables. But you want to predict something with multiple factors. Then now you can decide predictor and predicted outcome based on the correlation, based on the associated variables. Okay? So think about it, this one. So independent variable, dependent variables, these terminology, these terms are from laboratory experiment perspective. But we kind of generically just use that terms even in the observational study setting. More accurate term is just predictors or outcome variables, something like that, or X variables, Y variables. Okay. Number 2, here, this is GLM menu output. This is looks quite different, right? Compared to regression output. What do you call regression output? Regression output is a coefficient table, right? This is a test of between subject effect. Why is the title so complicated? Is the between subjects? What is the meaning of the between subjects? So this is kind of ANOVA style output. That's why they use this. So between subject means you have groups. Let's say female and male. Okay, 100 persons are in the male group and 100 persons are in the female group. So if you have some kind of variance between two groups, female and male, that is a between subject difference. Between subjects variance. But in the one group, you still have some individual difference, right? That's within subject difference or within subject variance or within subject effect. Okay? We expect the between subject difference bigger than within subject difference. But sometimes it's not. Like if you meet really, really crazy, women, like I'm a woman, but if I see like really, really crazy women, I have a feeling, oh, they are quite different from me. Or they might think I am crazy. But if I share the same kind of common sense with a man, these men might be kind of closer to me. So in this crazy example, within subject difference is bigger than between subject, something like that, okay? So anyway, what I'm trying to say is this title is not that complex. So this is, between subject, there must be some kind of groups, subgroups. So coronary incident, this is Chapman data, coronary incidence, yes or no group, right? This is grouping variable. And systolic blood pressure is a continuous variable, okay? So here we have two X variables and dependent variable is cholesterol, okay? So certainly this is called ANCOVA model because I don't see any interaction effect here, okay? I don't see interaction effect between two main variables, okay? So in this case, ANCOVA. If you see interaction between two terms, two main effects, then we call it ANCOVA plus or ATI model. What is the acronym of ATI. ATI is Attitude Treatment Intervention, okay, or ANCOVA plus. ANCOVA model is one X variable is continuous variable and one X variable is a categorical variable. That categorical variable should be converted into multiple dummies if you use regression tab. But if you use general linear model tab in the SPSS, you don't need to convert it into multiple dummies. That's why I'm using this general linear model more than regression when I run the analysis, okay? And I believe you're gonna do the same way, GLM model for your final paper. If your dependent variable is a dichotomous, if your outcome variable, dependent variable is continuous variable, okay? If your dependent variable is not continuous variable, even though you have X variable, two X variables, one is continuous, the other is categorical variable, you are not gonna run multiple regression or you are not gonna call it ANCOVA model. This is logistic regression. If you use the Y outcome variable is dichotomous. So I will have a chance to talk about the logistic regression later. That's actually in the end of this semester. Anyway, if your final paper has dichotomous binary outcome, then you have to use logistic regression and you need to see a different video or guide. Okay, I'm gonna make it soon. Anyway, so here you see one categorical variable and one continuous variable. This is ANCOVA model and no interaction effect. And so this is not ANOVA model, right? What is ANOVA? Let's say math score. If you compare math score among ethnicity groups and the gender group, you have gender and race ethnicity group. So you have two X variables, both of them are categorical variable. In that case, you use ANOVA model. No continuous X variable, okay? So ATI model, this is not ATI model because there's no interaction effect. Okay. All right, I think you can both main. Okay, so coronary incident below 0.05. So alpha is 0.05. So this is statistically significant. This is statistically significant. And we have included interaction effect. There's no interaction effect here. And the adjusted R square is a logical. Okay, where is the large R square? There's no R square here. Here. Okay. So, do you remember Cohen's rules of thumb? You remember Cohen's rules of thumb? R, small r, medium r, large r. You find out that slide said, okay? So then you can find out this one. So since it is multiple regression, you're gonna use this adjusted R square instead of this, right? Ceteris paribus, what is this? Controlling for. When you have multiple regression, you want to see the partial effect of the variable controlling for all others. Okay. I ran the ATI model here or ANCOVA. So that means what? You have interaction effect here. Interaction effect. Can you compare the two different means? What is two different means? Raw means. Subgroups, adjusted means. Subgroup. So you want to compare like disciplinary scores like that. What do you call it? Crime rates. Let's say crime rates. You're gonna compare crime rates across groups. You're gonna compare crime rates across groups. So let's say this is general grand mean. So whole mean, average, whole mean, regardless of group. Okay, here, cholesterol is outcome variable instead of crime. Anyway, this is mean. And we have no group, yes group. Let's say this is black group, this is white group. Let's say that. Or no group, yes group, coronary incidence, no group. So mean is 280, 315. Without any other controlling variables, this is just a naive mean. This is just pure, this is just naive mean and unadjusted means. Once you control some variable, after you use a control variable here, systolic, blood pressure, and yes, no, numbers are changed, compare that. So the gap between two groups is smaller than this, look at that. This means there are other important factors in addition to coronary incidence on the cholesterol level. That's why they use this blood pressure, okay? Okay, so now you can have the answer here. Number 5, GLM menu also shows a homogeneity test. Yes, this is good one. So in the midterm exam, we have a homogeneity residual plot, and between minus and +4, -4 and +4 on the y-axis, it's evenly, the dots are evenly spread, and that is a homogeneity test. Homogeneous equal variance. So here, equal variance assumption is satisfied because the null hypothesis is that, and this is not rejected because p-value is larger than 0.05, so it's not rejected. So that means that this null hypothesis is not failed. It's actually a good one. So we satisfy this homogeneity assumption. And now the further analysis is trustworthy. Regression analysis is trustworthy because this assumption is satisfied. So I think this is the only one test that we want to not to reject the null hypothesis. We want higher p-value in this assumption table. All right. So, but still, technically speaking, this is statistically significant. No? This is higher than 0.05, so it's not statistically significant. We reject the null hypothesis. Is this rejecting null hypothesis? No, we fail to reject the null hypothesis, right? Which is desirable. According to the above table, homogeneity will look like evenly spread. So evenly spread means equal variance is satisfied. Yes. Rejecting the null hypothesis is a good one. In other analysis, it's a good one, but not here. Fail to reject the null hypothesis is actually more preferred here, right? Preferred, okay? Let's read this one. Write the estimated regression model, parameter estimate. So parameter estimates is one of the output under the GLM menu. So whenever you write down your regression equation, you have to use this table under the GLM menu. Do you remember the question? Write down estimated regression model and identify all parameters and components in the model in the midterm exam. Do you remember that? Yeah, this is the same one. So what did you do here? Since this is estimated equation, what do you do here? Y hat, right? What is Y hat here? Cholesterol. So cholesterol hat equal, what is y-intercept? 245.932. So 245 9 round up plus minus. Coronary incident, zero group is no group. So no group is here, focal group. So minus 69, 3, 5, and coronary incident. And then 0 is, you multiply 0 to any number becomes 0, right? So skip it. Systolic is 0.563 systolic BP. And then this is interaction effect, interaction effect between two variables, coronary incident and systolic. So 0.329 coronary incident times systolic BP. So why this interaction becomes 0? Because coronary incident 1 was 0. So whatever number is multiplied by 0 becomes 0. So you don't need to write it, right? So this is it. So you can write that, identify parameters and components, right? Everything here, right? You remember that? Like, for example, systolic blood, what is this meaning? What is this number means? So when systolic blood pressure is changed 1 unit, and this number is changed in Y, cholesterol, right? Controlling for all other factors. So do you remember that? Okay, you have to write down everything. And what else? Okay, so here, some people confuse. Okay, some people confuse here. So when you coded this coronary incident in the SPSS dataset, you actually intended to use 0 as a reference group in the data collection and data coding stage. That's why it's 0 and 1. But with some reason, by the default, SPSS just compute opposite way. So if you see this number, this is focal group, and this 0 means this is a reference group. So even though this is coded as 1 is for yes, right? Yes group is a reference group here, and no group is a focal group here. So what you can say here, you have to write it down where, for coronary incident, focal group reference. The reference group is what? Reference group 0 here. So this is 1 is yes group, right? Yes group which is coded 아닌데. Yes group, reference group is a yes group. Sounds weird, but anyway. While the focal group no group. Okay. So focal group means 1. Reference group means 0. Okay. You add this line, okay, in addition to all other parameters and components, okay? Okay. When you write your final paper, introduction includes problem statements and some backgrounds about the topic and why your topic is important and how can you improve the current literature on the topic, by conducting your study, that kind of thing, the importance of your study. And then in the end of the introduction section, you have to write a clear research questions, okay? Not fancy one. Some people try to write sentences very complicated way in complicated, but I don't like it. And the simplicity and the clarity are the most important thing in the quantitative analysis class. The paper, quantitative method paper. Literature review. Literature review includes hypothesis. You shows all backup theories. Literature review, and then based on this literature, I suggest my hypothesis like this way. So if you make your hypothesis sounds more persuasively, you have to provide enough number of key literature, and logical coherence is really important. Okay. Methodology. Where did you get the data? You have to explain the participants and how the participants are collected. Is it stratified sampling or cluster sampling, something like that? You don't need to know that technique, but if you use secondary data, that the secondary data link might show the background of data collection information, right? Process. So you have to include that. Unit of analysis. Your unit of analysis is a person or agency or city, something like that. Okay. And your technique, analytical strategy is multiple regression. If it is multiple regression, is it ANOVA or ANCOVA or ATI model? If your model is logistic regression, if you have to say the logistic regression. I'm going to make another video for logistic regression. And the result, descriptive statistics, mean, mode, median, like that, and standard deviation and mean and minimum, maximum, and also, for sure, bivariate correlation should be included, okay? Because sometimes your mother, because this is not a contextual course, I do not know a lot of things about variables. You know more than me about your topic. But what I know is when I see the model, I want to compare the correlation table also together. That's why I need this one. And regression table. Again, I strongly recommend you use GLM menu instead of regression, because regression needs to go through multiple manually, manual conversion of variables into dummies. It's complicated. So if you use multiple regression, use the SPSS menu, GLM menu, not regression. If you use dichotomous outcome variable, you're gonna run logistic regression. And when you have regression, you're gonna report R-square, or, this means adjusted R-square, okay? Adjusted R-square. And test value, F-test value, or, not or, and t-test. Interpretation, you have to provide all the evidence table and figures. You want to show some kind of group comparison using bar chart or pie chart. You want to show the histogram and the residual plots in the end of the paper using appendix, assumption checking, okay? Conclusion, policy recommendations. So since you went through the study, you know more than me, and then you have to provide suggestions or policy recommendations for the audience. So read the syllabus, SLOs, students' learning outcomes. See the difference between 628 and 630. The main difference is, this is it, policy recommendation. 630 advanced class are supposed to provide this one. The 628, no need to. So, if you have any questions, email me. Okay, thank you. Bye-bye.